Today, the AI race is no longer just about building faster chips. The real problem is moving data fast enough. Companies like NVIDIA are helping build some of the largest computing systems ever created. And we're talking about AI campuses with tens of thousands of GPUs connected together at the same time. Meta is building multi gigawatt AI infrastructure. OpenAI's Stargate project could eventually require power levels comparable to entire cities. And XAI's Memphis supercluster is already becoming one of the largest AI facilities in the world.
This is the largest AI cluster in the world. The team at X is building a massive AI supercomputer that encompasses over 100,000 GPUs, exabytes of storage, super fast networking. This place is absolutely amazing. And this entire supercomputer is built to power Grok. Now, XAI is building something with Grok that is far more than just a simple chatbot like we've seen before. And that is exactly why there is a giant cluster here. Today, we're going to go back inside these data halls and show you a whole bunch of stuff on what makes this work, what makes this special, and just all the really cool engineering that went into this. Now, this is actually my second time at the facility, and let me just tell you, the speed at which this thing was built is absolutely amazing. This entire facility with over 100,000 GPUs was built in only 122 days. And just to give you some frame of reference, the largest exascale supercomputers only have a fraction, maybe half to a quarter as many GPUs as XAI has here, and yet those deployments generally take many years from start to finish.
But here's the problem most investors are missing. As AI systems scale, the amount of data moving between the GPUs explodes, and that creates a massive bandwidth problem. Because if GPUs cannot communicate efficiently, then training slows down, inference slows down, latency increases, and utilization drops. In other words, the GPUs become less effective. And this is why the next phase of AI infrastructure may not be won by the companies building the chips, but by the companies helping the data move. And in this video, we're talking about three companies positioned directly in the middle of this AI bandwidth explosion. In this video, we're talking about Applied Optoelectronics, AAOI, Corning, GLW, and Lumentum Holdings, LITE. Because AI is increasingly running on light and not just electricity. AI data centers are starting to resemble industrial infrastructure projects more than traditional server rooms. A modern AI training center cluster can contain tens of thousands of GPUs all communicating simultaneously. And that means the networking demand grows massively as these systems scale. Think about it this way. One GPU communicating with another GPU is very simple. But when tens of thousands of GPUs need to constantly exchange information across entire racks and buildings, the traffic becomes enormous. This is one reason networking speeds are rapidly moving from 100G to 400G to 800G to 1.6T and beyond. The amount of data AI systems need to process is exploding, and traditional electric connections begin running into limitations as higher speeds and distances increase. That's where optics comes in, because optical networking allows data to travel using light, which is faster, more efficient, and better suited for large scale AI infrastructure. This is one reason investors are starting to focus not only on GPUs, but on the entire AI networking stack surrounding them. You have Meta building multi-gigawatt AI campuses, which needs multi-gigawatt power capacity. OpenAI Stargate project from last video could require power enough to power entire cities. And XAI, the Memphis supercluster, is one of the largest AI facilities, needs hundreds of thousands of GPUs. The shift to optical networking, as these data centers age, they need to go from the copper wiring to optical signals, which is faster, more efficient, and built for massive scale. And one GPU is easy, but tens of thousands and the traffic explodes. Tens of thousands of GPUs and the traffic explodes, which increases heat, electricity, and so on. Modern AI clusters are enormous, tens of thousands of GPUs, millions of parts working together, exabytes of data moving across the network, power levels comparable to small cities, which leads directly to company number one, AAOI. Applied Optoelectronics, AAOI, is one of the more interesting smaller cap companies connected to this AI bandwidth theme.
And we saw a trend at Futurum that AI data centers are becoming more of these massive networking machines where GPUs need to communicate constantly across the racks, clusters, and memory layers. That creates a huge need for faster optical connections. That's exactly where AAOI fits. So the reason we got really interested in this name specifically is because data centers are now becoming moving from the older speeds to much faster, and AAOI owns a key part of that high-speed optical transceiver supply chain that gives them direct exposure to the bottleneck and the biggest re-rating among that group.
AAOI focuses heavily on optical transceivers. Now, what does that mean exactly? A transceiver converts electrical signals into optical signals and back again. And in simple terms, it helps data travel through fiber optic systems. And in AI infrastructure, these components are critical because GPUs inside AI clusters need to constantly communicate at extremely high speeds. Without efficient communication, these expensive GPU systems become bottlenecked. And that's a huge problem when companies are spending billions of dollars building AI infrastructure. This is one reason hyperscalers are aggressively upgrading their networking capabilities, because AI traffic inside these systems is exploding. What makes AAOI interesting is that it gives investors exposure to a very specific layer of the AI stack that many people still overlook. Most investors only focus on NVIDIA, but NVIDIA systems still require massive optical networking infrastructure around them. And that's where companies like AAOI potentially benefit, because AI GPUs are useless if they cannot communicate fast enough. The second company is Lumentum, LITE.
Modern artificial intelligence is reshaping the digital landscape. With large language models, massive data sets, and a growing need for compute power. Delivering this performance at scale requires more than hardware. It demands energy-efficient architectures, capable of moving data faster and more accurately than ever before, across global networks and within the world's largest data centers. Photonic technologies enable the optical connections that keep data moving. It's how AI systems communicate, from cloud-scale training to real-time inference. As a global leader in photonic innovation, Lumentum enables high-speed data transmission at scale, producing billions of components that power the backbone of optical networking systems that are foundational to AI data centers. Together with our partners, we're driving the technologies that make next-generation AI and advanced computing possible. At Lumentum, lasers power everything we do. Our advanced laser portfolio includes electro-absorption modulated lasers, directly modulated lasers, and high-power continuous wave lasers. These lasers generate light that moves data within and between data centers. And with our optical circuit switches, wavelength selective switches, and ROADM products, we enable networks to direct data, lighting pathways that optimize its flow inside the data center, between data centers, and across continents. Over the past 3 decades, as data demands have continued to rise, optical communications has expanded from long-haul networks to metro networks, to campus networks, to data centers. We are now on the cusp of a new frontier, in which optics will play a pivotal role to bring high-speed data over very short reaches between chips. This will power a new generation of AI systems, setting a new global standard for efficiency and performance. With decades of technical expertise and a commitment to responsible innovation, Lumentum is solving today's challenges and ready for what's next.
LITE fits directly into one of the most important things in AI infrastructure at the moment. AI runs on light. Lumentum develops optical and photonic technologies, including lasers used in high speed optical communication systems. Now, this matters because electrical connections begin struggling at higher AI networking speeds. And as AI traffic increases, companies are increasingly turning towards optical communication solutions. Why? Because light can move enormous amounts of data efficiently across larger distances. This is becoming critical as AI campuses continue scaling. And this trend could accelerate even further with technologies like silicon photonics, co-packaged optics, CPO, and advanced optical interconnect systems. In many ways, AI infrastructure is beginning to shift from electrical scaling problem into optical scaling problems. And that's a huge transition because if the industry continues moving towards optical networking architectures, companies involved in lasers and photonics could become increasingly important. And that's one reason names like Lumentum, Coherent, and MRVL continue showing up in conversations surrounding next generation AI networking because the future AI data center may rely heavily on optics and not just compute. The third company is Corning, GLW.
NVIDIA and Corning are pairing up on a huge announcement today that could totally flip the script for the AI build-out. Corning is building 3 new factories entirely devoted to products for NVIDIA in North Carolina and Texas. And while Corning and NVIDIA didn't share many specifics, it's likely the deal is worth tens of billions of dollars. This could be the big deal many analysts have been waiting for, the debut of a new technology called co-packaged optics. It could eventually mean NVIDIA replaces the 5,000 copper cables 2 miles worth inside its rack-scale systems like Vera Rubin with tiny glass fibers made by Corning, something that until now has never been accomplished at scale. Co-packaged optics would vastly reduce the energy needs of an AI data center because glass is far more energy efficient than copper. It also means lower latency for all those AI tasks because fiber optics can send data far faster than copper, allowing faster communication between the hundreds of thousands of GPUs in an AI data center that need to act as one to execute AI workloads. Unlike traditional copper phone lines that transmit information as electrical signals, fiber optic cables are tiny bendable strands of glass where data is sent through as photons, lasers emitting pulses of light at far higher speed using less energy.
Moving photons is between 5 and 20 times lower power usage than moving electrons. So basically, as power becomes a bigger and bigger issue, fiber inevitably gets closer and closer and closer to the compute.
AI infrastructure does not only require GPUs and networking hardware, it also requires physical fiber infrastructure, massive amounts of it. AI campuses need data moving, rack to rack, building to building, and sometimes campus to campus, and that requires enormous fiber deployment. And Corning is one of the biggest names in fiber optics infrastructure. This is important because the AI boom is becoming to resemble a real world infrastructure expansion cycle, almost like the digital version of highways, railroads, or power grids. These AI systems are becoming physical infrastructure projects, and fiber acts like the highway system connecting everything together. Without enough fiber capacity, traffic slows, latency increases, and scaling becomes much more difficult. So while companies like NVIDIA may dominate the GPU headlines, the supporting infrastructure behind the scenes could become just as important, and that includes fiber. Most investors still focused almost entirely on GPUs or AI models or software, but one of the biggest hidden bottlenecks may actually be bandwidth. because AI scaling requires faster communication, more optical networking, more lasers, more transceivers, and more fiber optic infrastructure. And that's why companies like AAOI, LITE, and GLW are becoming increasingly interesting to watch. And this may only be the beginning because AI traffic continues exploding over the next several years. The companies helping data move efficiently across these systems could become some of the biggest winners in the entire AI infrastructure build out. And the next phase of AI may not simply be about who builds the smartest models, but who enables the data to move fast enough to power them. And if you enjoyed this video, make sure to like and subscribe to the channel because we're going to go deeper into the AI infrastructure build out, hidden bottlenecks, and the companies powering the next phase of AI growth. If you want even more research, portfolio updates, or early access videos with exclusive member content, check out the buymeacoffee.com page, 20-minute stock hunt. That's where I post additional insights, deeper dives, and member-only updates on the stocks and themes we're covering here on the channel, plus other stocks not covered on the channel that have 10x potential. So thanks for watching, and we'll see you in the next one.